In this video, I'll show you how to set up an Hyli node on your computer and build a simple app. And then also showing you the Blackjack app we did for testnet and how it works. So let's get started right away. The first thing to do is to clone the Hyli node. I'll start sharing my screen as well. I'm in the Hyli folder now, and I can go on the docs actually. And yeah, you need to install Rust, a bunch of stuff you can figure out probably. The first thing is to check out to the v13, 0.13 version, where it's stable for devs. If you go on main, like it's going to be quite unstable. So let's go on v13 and run this command. So it's going to take a bit of time to compile, but I already did compile it before. Then the next step will be to actually run the scaffold. No, not the scaffold, sorry, the wallet. If you look at the docs, we need the wallet because Hyli is doing off-chain execution. So okay, the node is running. Because we do off-chain execution, we need to have a server that actually does the execution. So the wallet server is here for that. So as well, it's already cloned for me. And we also need to check out to 0.1.2. So let's do that. If you look at the wallet folder, you'll see that there is a front-end server contract. That's going to be the case for all the apps we build right now with the scaffold. So yeah, just get used to that. And we can run the wallet server as well with the right options. And also don't forget to add the RM at the start, because if not, it's going to not work as expected. Also, I didn't say it, but you need to have Docker running for the node to work. So yeah, let's run the server of the wallet. And we can already prepare, the fact that we're going to go to the App Scaffold next. That's already cloned as well. And we can just run the server as well. Okay, maybe let's wait for the wallet first, because my computer does not really like to have two different Rust compilation at the same time. Yeah, so the wallet is registered, everything works great. Let's do the scaffold now. And we can also, as I was telling before, there is like all these folders. And we can also go to the front end part to first install it and running the front end. Okay, the server is also working. And we can go to the localhost to see our scaffold running. We have the app scaffold. You can connect your wallet. First thing is to create an account. You can use the default things. It works right away. It's gonna generate a noir proof right now. This is only on front end, by the way. It's using our wallet library. Okay, so now we're connected. We have a very simple interface for our very simple scaffold. Okay, let's look at what's inside the scaffold now. So if we look at the contracts folder, maybe I'm gonna actually do it a bit more. Okay, if we look at the contract folder, you can see there is two contracts, just like here. The contracts, I think, are the same, and they are very simple contracts, and they are both using Risc0, I think, but you don't even need to care about that. So we can look at the lib, and okay, maybe let's zoom a bit. And you can see it's only Rust, only writing in Rust. We have a trait ZK contract that we implement for contracts, and we have this execute function in the ZK contract trait, the entry point of the contract logic, as the command says. And we are parsing the call data. So basically, the call data is the parameters you send to your smart contract. We are parsing the call data and matching an action. That's how we do it. Here, this contract only has one action, which is increment, that we can probably try if we click this button. It should work. Okay, transaction hash has been sent. It's confirmed. And okay, if we refresh is just refreshed, we can see that both contracts have been incremented. So it's a very simple contract that increments self n plus equal 1. Very simple contract. What we can look at as well probably is the server, but yeah. What you need to know basically is the way we write contract here at Hyli is having a contract one action, which gonna implement all kind of actions that the contract can do, like a transfer, a burn, a mint, whatever you can find on like ERC20 or something like this, whatever you want to do in general. And then we're gonna have this execute entry point where it's just like redirecting to the right place. We're gonna take a look later at the Blackjack contract to make sure it's easier. So I think a great thing to do is to look at the server as well quickly. It's gonna help understanding what the server does, of course. So we can look that there is an increment endpoint here that the front end is calling, and basically it called the send function that's right here. And as you can see, we create the two actions that we want to do because the send is actually doing the two actions at the same time, the two contracts at the same time. So we have the increment action for contract one, increment action for the contract two, and we have the wallet blobs that we are getting from the front end directly. I'm not going to cover this part on this tutorial, but it's really easy to set up. You just pass it in the API. It's all done in the GS lib we have. And then we take these actions and we convert them as blobs. So we have as blob trait that we implement. I think if you implement there's probably an action trait you can implement that will convert them to a blobs as well. So yeah, and the blob needs the contract name. And what's a blob basically, if you don't really know the Hyli infrastructure, it's basically you're committing to the parameters you're going to send to the contract. So if for example, you would think of a transfer from Alice to Bob, we would commit that Alice will send 20 to Bob. And we're going to send this as a first transaction called the blob transaction. And then we're going to send the proof that this transfer from Alice to Bob of 20 oranges is valid. So that's what we do now. We create the parameters we're going to send to the chain, and we send the blob transaction with the blobs. So our blobs here are, I'm going to increment the contract one and the contract two. And then you don't really have to care how it works, but we have in our server something that auto-proves this transaction. It's going to listen to all the blobs from certain contracts, so your contract will work as well. And then auto-prove using, for devs, it's going to be in dev mode, so the proof are going to be fake, but in prod, it will be like using a boundless or SP1 prover network or any prover network, your own infra if you want, but it's going to use some proving capabilities just to be your contract. Okay, I think it's fine. It was clear. So we can take a look now. Okay, so yeah, just to finish, of course, if you want to write a contract, I would advise you to start from contract one and go from there and see your changes happening. We can start looking at the contract from eZKasino. So if you don't know eZKasino, it's our casino game that we have in our testnet. So yeah, we have this casino game. I'm not even logged in, so I'm not going to do it. But this is the contract. It's just a blackjack game, very simple blackjack game. So for the contract, as I was telling you, we have this execute entry endpoint that's going to parse the parameters that we give to the contract, getting the user as well. And now it matches the action. We're going to look at one action today, which is going to be the it action. So because the way we design the blackjack is every action you take is one transaction. So a new game is going to be a transaction each time you want to eat, so get a new card from the dealer, it's going to be a new transaction. When you stand, it's a transaction. When you do anything, you can see all the different transaction here. So we're going to look at it. So we're going to look at sell.it here, and it's just basic blackjack logic. I don't think there is much out of there is not much smart contract logic here. We just have something important, which is the block hash. We have the hash of the block. Probably didn't write this contract. I think we use the hash of the block, the RNG. So it's probably not the best random. The casino could lose money out of that, but it's just a testnet game. So what we do here is first getting at the table of the game, basically. Table is the game, and doing some safety checks, getting the RNG, and then we call pick random card, which, as you can guess, pick a random card, and then computes the score of the user based on this card. And then do checks, like if it's 21, then the user won. If it's less than 21, we give the option to the user to continue eating or doing different options. And if it's more than 22, it should just crash. Yeah, more than 21, you lost. We have a table state that says lost. Okay. It's just a simple blackjack logic, basically. Not really much going on here. We can also take a look at the server here, because it's going to be interesting to see where we hit, what's going on when we hit from the server. So let's find hits. So it's basically sending the blackjack action hit with the wallet blobs I was telling you about earlier. Okay, and if we get to the send part, then we do like the action as a blob with the contract name, and that's the only thing we really need to do. With the deposit and the withdrawal, we need more stuff, but that's not really important today. We need more stuff because we need to also check some token transfer that happened. I don't know if it was crystal clear. I hope so. But the idea is that it's very simple to write a smart contract. Most of the logic in the scaffold is already done. You just have to write your logic. And if you need anything, you can contact us. If you want to do more difficult parts, you can watch the other videos that's kind of covering Orange Trail and different other apps. And yeah, like just go build cool stuff. We can't wait.